Here we go, and we're live. So welcome everyone to our last virtual jug session of 2014. So with me today we have Mr. Dick Wall. How are you, Dick?
I'm doing very well, thank you. How are you?
Great to have you, Dick.
Oh, very good, thanks.
Thanks.
And whereabouts you joining us from today?
I am in Birmingham, in the UK. I'm over visiting various families and stuff like that over the Christmas break. So yeah, I apologise in advance if there's any problems with internet on this one. It's it's travelling, and when you're travelling, you sort of get what you've got as internet. So hopefully it'll hang in there. We have a backup phone just in case things go horribly wrong.
Well, thanks for joining us on your vacation.
Yeah,
thank you.
Absolutely. And I assumed you were US based at the moment, but I didn't realise you're only a couple of hours away from me right now. I'm down in Basingstoke at the moment.
You could be in Simon's tiny, cluttered office with him right now, not with your family.
Not much space.
Maybe
There's not much space.
Well, maybe it would have worked out better for the internet, but this is very comfortable, and I'm looking forward to beer after this. So.
Excellent, excellent. So, Oliver, we're doing a session on Scala. What does Rebel Labs have for us on Scala?
Oh, Rebel Labs has so much on Scala over the years, actually. We had a great report come out in the early days of Rebel Labs, in which Martin Odersky himself was a very generous guy with his time, and he gave us some great feedback, and Josh Swareth as well. We followed that up about 6 months ago with our Java Tools and Technologies report, where we saw Scala really jump ahead of at least my expectations of popularity. Nearly half of Java developers surveyed said that Scala was the next thing they wanted to check out. So this kind of has been something that's been really interesting to watch over the last couple years, and I'm interested to personally learn a little bit more about Scala code today. So I hope you guys are too.
Yeah, it did hit an inflection point about that time, and a really big thing of a tick there. So, okay, so shall I just take it away?
Let's do it.
Awesome. Just a couple of things I want to mention before.
Okay.
Just to wrap up 2014. This is actually our 30th session in total now,
Wow.
and we have 2,356 members. So please do share that across your teams. Let's try and get this group even bigger. Any questions that you'd like to ask Dick throughout the session, please pop that in IRC. We're on Freenode #virtualjug as normal. Any questions that you pass through that, I'll either ask Dick as we go or at the end, depending on whether we've moved on or how relevant it is at the time. So yeah, without further ado, I'll pass over to Dick now, and let's go through the session.
All right. So I think everybody's seen enough of my face, so I'm going to do the screen sharing thing here.
Me too.
Screen share and internal. Right. So hopefully you guys will see this. So very roughly, the agenda is going to look a bit like this. I'm basically, the intro is what I'm doing right now. I'm here to talk about Scala for Java developers, and really, in an hour, I'm just going to try and concentrate on some of the things that are different and some of the value you can get from Scala immediately. So I'm going to look at the REPL, which is it's the interactive shell. Talk a little bit about vals and immutability, and then we'll have a look probably at the first real value add that you get from Scala, which is case classes. They're sort of best practice value classes or value objects. And then we'll take a look at objects and companion objects and what they do. Operator notation, the much hyped or argued about operator overloading that people worry about. Scala doesn't really have that. It actually has just operator notation, and I'll show you some of that. And then if we have time, we'll get to some of these later ones, function literals, options and futures, what map and flat map are, and how the for expression works, traits, and then a whole bunch of stuff on implicits at the end, which will build to some fairly advanced stuff. It may be that it's going a bit too far, but even if you don't get what's going on, it's kind of cool to see what's there and some of the more advanced things that you can do. So, you guys still hearing me okay? Oh.
Yep, everything sounds good.
Yep.
Okay. There was a bit of a pause.
Takes a while to go off mute.
As long as that's all right. That's as long as things are coming across. Right. So intro's done. Let's have a look first of all at the REPL. So the REPL is the read, evaluate, print, and loop. Let's come out of this and actually start it. So you get it just by typing Scala at the command line. And really, since using Scala, the REPL, even after 5 years of programming in Scala every day, the REPL is something I still use every single day that I'm programming in Scala. It's really useful to just try stuff out and experiment with. And it would be hard at this point to go back to Java or a language that doesn't have this kind of interactive shell. It's something I even missed before starting with Scala because I use Python a lot. And it's a real advantage in Python to just be able to type things and try them out. And then put them into code. So, sort of thing you can do here is if we just say something like 6 times 7, we get, of course, 42, the answer to life, the universe, and everything. There's a few things that are pretty nice about this. First of all, it assigns the value. If we don't assign it a name, it actually sticks it in a res 0, and we can do things like just say minus 1 times res 0 to use that, and now we get the next result, res 1, and it just gives you a whole bunch of memory positions for these values, so you can refer back to earlier parts of the calculation. And then, of course, Scala has inferred typing. So we didn't have to say that the result was an int. Because we are taking an int and multiplying it by an int and the result is an int, it automatically infers that for us. And we could, if we want to, create a val and say val x of type int. So you can optionally type things even though the type inference is there for you. But if you explicitly type them, what the compiler does is type checks it to make sure it's correct. So if I say x of int equals 6 times 7, that's fine. But if I was to change the second one to a 7.0, that's now a double. Multiplying 6 by 7.0 results in a double, and that will be a type error in the compiler. And don't worry about the long thing. What it's actually looking for when you do this, in the way that I can say something like val d of type double equals 8, you'd expect this to work in Java as well, because there's nothing wrong with putting an int or a long into a double. It's an automatic widening that happens. And in fact, Java has these implicit conversions like Scala does. The difference is that Java has them defined for a very small set of fixed cases, whereas in Scala, it's a general feature, like most of the things are in Scala. They're not specific rules. There are general kind of features like implicit conversions that are defined, and some of them are predefined for you. So int to double is automatically defined. Double to int is not. And so when the compiler hits that, it actually tries to look around and see if there's anything that can do that. But what it comes back is it says it's a type mismatch. That's what we really care about, is the result of this is not an int. Likewise, if we did val x of int equals hello, which is a string, we get another error, a type mismatch, and it says it requires an int, but it got a string. So that's the REPL. It's really handy if you want to just try things out, like, for example, if you want to mess with Java libraries, we can import Java util date, and then we can say val date equals new date. And another nice feature is you can say date dot and hit tab, and it actually gives you completion of the methods that it knows about on there. So we can say, for example, get year. It's probably bad, yes. All these things are deprecated now. I should be using the new datetime API in Java 8, but actually I'm still running the Java 7 JVM at the moment, so some of that is unavailable to me. I could have imported Yoda time if I'd have thought about it, but yeah, we're just going with the old familiar date. So,
so Dick,
yeah.
So there's an interesting discussion in RC right now about the need for REPLs, because one of the languages that we had a session on earlier this month was Ceylon, And Gavin King, I'm sure you know Gavin, is the creator of Salon, had an interesting view about REPLs, which is with the way IDEs have evolved and do so much for you. It was his belief that there is absolutely no need for a REPL. What's your use case for a REPL, given that we can do so much in IDEs?
Well, I have one right here. Then, in that, well, it's maybe an unfair use case, but I'm actually demonstrating this off of a Chromebook that just has a terminal, and so I couldn't actually do what I'm doing in an IDE right now because I don't have an IDE in this to demonstrate it on. And I actually do use this machine for development work. You know, I do actually have an Ubuntu installed on here, so when I need to, I can boot and use an IDE. But I can get a surprising amount done just in the REPL. I do think that some of the worksheets that are available, they have some very nice features in. I still end up coming back to the REPL time and again, even though I use worksheets. And I think that once you've got used to it, there's something just more interactive about a shell or a REPL than, say, a worksheet where you sort of type the commands in and then sort of you still run it in this kind of cycle of type and run. So I do find this lends itself better to exploration.
Okay, thanks.
Okay, so anything else about the REPL? Probably not. Let's move on to vals and immutable data structures. So if you follow best practices in Java, one of the things that you know, and I picked this up from my time working at Google, is that you really ought to consider making variables final. One of the reasons is that you don't want to accidentally reassign them. You want to make it easier for people to reason about your code, so wherever they see anything that's final, they know that it cannot change, so therefore they don't have to go tracing through code and see if somebody's changed it or side effected it somewhere. But one of the other things from Google, again, the code kind of style guides, is if you put final everywhere, it ends up really cluttering up the code. So it's considered overkill to put final on absolutely everything, like parameters and stuff like that. And what Scala does instead is it gives you two keywords. You've got val and var. So if I say val x equals 6 and var y equals 7, you make the decision and you create these things. So now val is effectively a private value, a private variable. Sorry, a final variable. Whereas var is a mutable one. So I can't say x equals 10. That's a compile error, but I can say y equals 10 now. And really what Scala's doing here is putting these vals on an equal footing. And in fact, it puts val slightly ahead of var in that, for example, if you do things like def my method x of int and y of int, and you were to say something like, we'll return a Boolean from this, and the result is going to be x, and what I want to type is x equals y, but what I'm actually going to type is x equals y, a common mistake when you're in a hurry. And what this would do is reassign x to y in Java. That's a compile error because x and y actually come in as vals in parameter lists as well. So there's this sort of gentle nudging towards the more immutable way of working. And another way you see that is with the collections library, which is you know, a fantastic API in Scala. Really, really nice, consistent, homogeneous set of collections. So if I say, for example, list 1, 2, 3, I get back a list of 1, 2, 3. And this is immutable. I can't just say res 3 plus equals 4 or something like that. That again is well, first of all, it's looking for a method. I'll get to methods in a minute, but I can't just change this. I can't say res 3 equals res. Actually, let's assign it to a value. So val x is list of 1, 2, 3, and then if I say x is equals x is plus 5. Again, reassignment to val, and you can't do this. Now, there are operators that let me do things with lists, of course. It'd be useless if I didn't. So I can, for example, stick a 0 on the front of list by using the cons operator, as it's called. But that actually gives me back a new list now, and it's very efficient because it's adding to the front of the list, and it's actually sharing the same. The tail is the same list that I had before. We can see that if I say res5 and then just .tail, you can see it's the same things. But if I say basically EQ X's, which is identity in Scala, it's are these objects actually identical, using the same memory address and everything like that, it comes back as true. So you can see that it is actually reusing the original list. And this is something that just runs throughout the immutable data collections. There's another very nice collection called vector, and this is not the unsafe Java vector that you're not supposed to use anymore because it's too heavy with synchronization and has all these problems. This is actually a very, very modern, clever data structure that efficiently reuses all of the parts of a vector, or of another vector that it can. So if you update something, it actually just copies sort of a sliver of the tree and leaves everything else the same. So you can get thousands of these immutable vectors sharing a lot of common data in memory at the same time without having to make duplicates of them all. So that sort of thing. So, you know, the kind of immutability is woven into the language in terms of the val and the data structures. You do have mutable ones, of course. If you want to use them, you can import scala.collection.mutable. And, of course, as I demonstrate these things, there's all these features that I forgot to put in my script which come up, like the fact that you can actually import the package itself. So I've just imported the mutable package, not the contents of it, actually the mutable package by name. So I can now say mutable.listBuffer.empty of string. And that is now one of the mutable collections. So now I can say, for example, res9 plus equals hello, and it adds it, and then I can say world, and that's a mutable one. So this is actually, you know, building up a mutable data structure, and at any point I can turn it into an immutable one by just using one of the conversion methods. So this is also a common technique if you want the performance of mutable, but you don't want to leak mutability into the outside world, which is always a very good idea. There's lots of these kind of conversion methods that make everything back into a safe, immutable data structure at the end of the use of them. I'll give you guys a moment to ask questions as I check that off. Anyone? Are you guys still hearing me?
Oh yeah, sound
okay.
quality seems to be good.
Oh, excellent. Okay, I get no feedback at this end because, you know, I'm talking away.
Right.
myself. I may have stopped broadcasting 10 minutes ago, and I'm still nattering.
Yeah, we all went offline to have dinner.
Oh, it's really riveting. Then I can tell. Okay.
Simon, you have some questions in the queue?
I haven't looked. Yeah,
I have one or two, but I think for the minute they can probably wait till the end. Harmeet's got an interesting one. Does Scala use Java Collections APIs?
You can access the Java Collections APIs. The only collection that Scala uses directly from Java is Array, and that is for efficiency reasons. Array is the most performant collection. It has native support in the JVM. So to not provide that would have been to shut off the potential for a lot of performance optimizations. However, unless you need the performance, people generally don't use arrays in Scala. They're not very safe because they are mutable. They're filled with nulls when you get them. There's kind of all these traditional problems of using them. So it really is sort of a last ditch. We really need this thing to run fast. So we're going to use arrays even with the problems they have because they're incredibly performant on the JVM. And for everything else, people tend to stick with lists and vectors and stuff like that.
And talking about performance, what's the kind of performance between a Java list or a Java vector compared to a Scala list, Scala vector?
Wow, that's a really big question. It's a very good question. The neat thing about immutability is that it can be incredibly performant if it's used in the correct way. So Scala list, for example, because it's a true linked list, that actually shares the tail with other linked lists. So, by way of an example, nil, which is the empty list, This specific nil, there's a single instance of this in the JVM, and it is the end of every single list in Scala. So there's all sorts of performance optimizations that you can do just with that alone, and many others that you can do when you add something onto the beginning of a list. If you were wanting to retain a copy of that list of the original list in Java and have the new one, that would be a copy operation that would take a period of time. In Scala, it's a constant time operation. It just adds one item onto the beginning of that list and gives you back a reference to it. So I think the answer you're probably looking for is if you're comparing apples to apples, immutable data structures usually carry a performance overhead with them because they are immutable, and so there's extra steps that you need to go through. If you know the characteristics and use them effectively, they can actually be very much more performant than Java, particularly when you get into parallel processing and kind of multiple threads that are using the same or shared portions of the data at the same time. Because they're immutable, you can pass these things around without any synchronization, without copying, all of those kind of things that you would do otherwise, and the code can end up being quite a bit more performant as a result. I can also put some numbers on that as well if need be, which is I have written code that performs. I know this is going to sound like a wild claim, but I really can back it up. Performs not only better than Java, but actually performed better than the C++ code that it replaced. And the reason it performed better than C++ was Hotspot optimized things that C++ couldn't optimize. So we got all of the advantage of using an immutable vector data structure in a way that made sense. It was basically a Monte Carlo simulation, so it was doing hundreds of runs at the same time and sharing as much of that vector as possible. So we were getting all the advantage of that, and we were getting the advantage of the JVM. So yeah, performance hasn't been a concern for me using Scala since I started using it.
It's great to see that the C++ guys have now got flame wars with both us Java guys saying we're faster than them, and now the Scala guys too. That's awesome.
Well, the JVM hotspot just-in-time compiler is an unfair advantage. It actually gets to see what's running as it's running, so it can do optimizations that you just couldn't do in C or in a natively compiled language. So occasionally that's a big win. Or at least a reasonable win. It was about 20% faster than C++ in the case that we had. So nobody really cared that much. It was a batch job, but it was a curiosity that it was actually a little faster. Mm-hmm. So, okay.
Awesome. No other questions.
Oh wow, I've bored everybody into submission. Okay, I'm going to show case classes next then. So these are wonderful things. They're one of the first things you learn as you come to Scala from Java, and even now I think that they make a tremendous basis for good style and excellent programming. And in fact, they make a pretty nice API as well. So to make a class, let's say class animal, and we'll have a name of type string. That's a complete class definition right there in Scala. It's not a very useful class. You can't even get name back out of it in this case. It's just it has a name that you construct it with, and then the name kind of disappears and is internalized into this thing, and you never see it again. So it's a bit useless. So if I say, for example, val an1 equals new animal, and give it the name I don't know, gosh, Paddington. That's a good one, Paddington Bear. So all you get back is animal with some, typical address, and I can't do anything with that. I can't get the name back out or anything. I could write all those methods, and that's what you would do in Java now. Is you'd fill out, kind of the typical bean pattern. You'd implement the getters and the setters if it was mutable, the getters and setters. You'd implement the equals and the hash code and the toString and all of that stuff. So if I just take the same code, but I say case class animal, and just say name of type string, now I have a very different beast. So I can first of all, I get a whole bunch of things with it. One of them is a factory method. So you can drop the new, which doesn't sound like a big deal until you start nesting these things inside of one another. And then it's a big win because you've just got rid of all these kind of new keywords all over the code. So now I can just say animal Paddington, The next thing you'll notice is I have a toString now, which tells me what I've got. It's an animal with the name Paddington. I can say, I should have assigned it to something. So let's say val and2 equals res15. So I can also say and2 and hit dot, and you can see a whole bunch of things here. One of them is that name, which is the field I used, is what we call a parametric field now. So it's immutable, but it's exposed so that I can get the name whenever I want to. And for data access objects, this really is kind of the best practice now of make it immutable and then just give it back instead of encapsulating it and hiding it. If it's immutable, there's no harm to allowing it to be seen from outside. Another thing I can do is an equals. So I can say, is this equal to an animal called Fred? And I'll get a false. But if I stick an animal Paddington in there, I get a true. And so equals is written for you, which is really nice. You know, that's a whole bunch of lines of code right there. Some other things you can do, one of them, actually, let me create now a person class, case class person, so it's a bit more interesting. We'll have a first name, a last name, and an age. Oh, and age of int. And now if I say val Harry equals person, Harry Potter, and I believe he's like 29 now or something, if you actually will figure out the age. That's a little scary. So now we can just say Harry, and we get person Harry Potter 29. I can also do, because this is an immutable, you know, it's built on the best practices, so the fields in it are immutable. I can't just change them willy-nilly. So I can't say Harry dot first equals Sally. That's a compile error. What I can do, though, and this offsets a lot of the downside to having these immutable objects, is I can say Harry.copy, and then Scala also has default and named parameters. So I can say copy, but change the first name to Sally when you do the copy. And now we get back a new object that is based on the existing one, but with that one thing changed. And this really gets rid of just about the whole downside of using the immutable objects or immutable classes. It's really easy to create new ones based on that, or change them. If I want to make Harry 1 year older, I can say Harry.copy. You'll notice I'm going back to Harry because it's immutable, so I can make another copy, and I can just say age equals Harry.age plus 1. And now I've got Harry Potter, but he's a year older. And this could go back into the database or whatever else I wanted to do. So this is very, very nice to be able to do. And of course, there's one more thing, which is my Harry, which is person. I can actually do pattern matching on this. And pattern matching is, oops, not cat, match. Pattern matching is just an amazingly powerful thing when you come to Scala from Java. It's like a switch statement, but much, much more powerful. And in particular, anything that has an extractor can be pattern matched to any depth that you want to. And case classes, when they're created, have this thing called an extractor. So I can say case of person, and what I'm specifically looking for is a person with a first name Harry, and I don't know and I don't really care what the last name is, but what I want is the age out of it. So now what I'm saying is find me a match for Harry, and if we get that, then let's print up the age that we got. In case of anything else, we'll say print line no match. And so now we get up that the age that's pulled out from this was 29. If I was to put Sally into the same, oh, let's try that again, but change it to Sally this time. So Sally doesn't have a first name of Harry, and do the same thing again. And did I not? Oh, I didn't assign it to Sally. Val Sally equals.
It was res 20, I think.
Oh, really? I was just going to make another copy, but let's see. Sally was res 20. Yes, you're right. So res 20. Okay, good enough. And now let's try that again. Sally match, and the same thing. and now it says no match because it actually does unpack it and check that that first one is a constant match with the name Harry, and then would give me the age. So all of this value, I reckon on something that's about 3 or 4 fields, you're basically getting about close to 50 lines of Java code just automatically created for you by Scala when you use a case class, and they're usually sort of one-line definitions, and they're a tremendous way of modeling your domain. In fact, that's usually where I start with problems in Scala now, is to sit down, figure out the domain model, and then just code it up in case classes very quickly, and immediately start messing with it and refining it. So it's a really nice way to work. Okay, how are we doing for time? And any questions at this point? I guess not. I'll keep rolling.
No questions at the moment.
Okay. Right, so I'll keep rolling then. One more thing, I'm probably not going to go into companion objects. There's something you'll hit as you go through Scala. Basically, a companion object, well, I'll talk about objects first. All companion objects is they share a special relationship with the class that's named the same as them. And they get access to private members and private fields that you wouldn't otherwise get access to simply by the fact that they're the same name and they're defined in the same source file. What an object is Scala doesn't have static methods. It's more of a traditional model for OO, if you want to look at it like that, than a language like Java, which uses static methods to get around the idea that it really has no case level methods or fields. In Scala, what you have instead is an object which is a true singleton. So if I say I've got my person now, and I can say object Fred extends person, and what we're going to extend is person Fred Jones 22, and this now is basically what it's doing here is it's defining a true singleton, and it's defining the shape of the item as well as the only instance of it. So Fred is actually now, it's, as you can see here, its type is Fred.type. It basically is this one type in the system that is a Fred. But what we can do is we can assign it wherever we would have used a person before. So if we say LP of person equals Fred, that's fine to do because it is a sub. Even though it's a singleton, it's a subtype of person, and we can use that object anywhere in the code now, just like it was another person. So you get true singleton with this. It's also a place where it's often used as a sort of organizational thing. So if I want to put in here square of a number of n int equals n times n, util is now just in this context, it's just an organizational construct for putting methods that you want to use wherever you want to use them. So I can now say util.square, and we'll give it, I can't type, square 5, and it gives me back 25. So in this context, it's a place to put methods and access them easily. It's also a true singleton. It's capable of being a whole bunch of different things depending on what you need. Objects are just very nice, and it negates the need for any kind of singleton pattern implementation like you would see, for example, using the gang of 4. It doesn't solve all the problems that you still see with overuse of singletons in code. If you've used singletons widely in enterprise projects, you end up with something called static cling. And if you overuse objects, you end up with the same thing. So you still want to be careful about overuse of them, but it's a very much easier way of getting the kind of advantages of a singleton when you use them carefully. Okay, so that's objects. Operators is the next one. This is kind of hotly contested because Java, of course, doesn't have operator overloading. C++ did, and it was considered the root of pretty much all of the evil, or much of the evil in C++. Other languages have flirted with it. Scala actually sidestepped the whole issue. So believe it or not, Scala doesn't have operator overloading. What it has instead is the ability to create a symbolic method name. So we can say plus and put in there, for example, n of int, and our plus method can simply add 5 to that number if we do it like that. So now we can just say plus and give it 6. And, oh, actually, that was a bad example to use. Let's use something like plus. But the reason is Scala actually has a meaning for plus already in that context, and I'm trying to override it, and it doesn't like that. So let's give it plus instead, and just say plus 6. And now we get 11 back. So that's the first thing. Scala allows you to use symbolic method names. And we could have called this thing def +++, and got exactly the same kind of thing out of it. So n of int equals 5 plus n, and just type that out, and you can see plus. So they sidestep this problem very neatly, because people say, well, you know, operators mean nothing. Well, I would say plus, a lot of the times to mathematicians, means a lot more than typing out plus, or you know, other things like, for example, one that is quite nice to use in testing is you say something like double, some kind of double value, and you're testing it for, or asserting it for equality to 5, but of course in double, you know, when you're comparing doubles, you can't do a straight up compare, because sometimes it will fail because of rounding errors. So what you do instead is you basically say plus or minus 0.001, for example. And that is a very nice way to look at that gives you basically the rounding error kind of solution. So you have symbolic method names, and you also have the ability to call things infix. So to demonstrate that, if I start off with hello and say char at 1, we should get E. Anytime, this is a general rule of Scala, anytime you have some item, which in this case is the string hello, followed by a method, followed by a single parameter, you can rewrite it to what we call infix notation. And you can get rid of the dot, you can get rid of the parens, and so you get hello char at 1 is exactly the same thing. It's basically a rewritten form of the above. So when you combine those two things together, you get something like this. If I say 7.0 times 2.0, and I get a double back of 14, what I can also do is say dot and put it into this form, and I get the same thing back. Both of these are equivalent. Infix is a style that you choose to use when you need it, and adding symbolic method names means that you can basically use whichever style is most readable and makes the most sense to the people looking on. So gone are the days of saying sort of big decimal. Let's see, import java dot. Where is big decimal in the Java world? Anybody remember? Is it under math?
Guessing math or lang.
Let's try math dot big decimal. Okay, so in big decimal, if you say, you know, BD1 or BD1 equals new big decimal and 10, then we have to do this thing of saying sort of BD1 dot, I can't type it, BD1 dot plus, and then you would say, you know, 6 or whatever, and all those kind of things. Oh, I need to provide the, you know, new big decimal around it. It gets really ugly very quickly. In Scala, which I now need to come out and restart, but big decimal here should be imported, I think. This is kind of static. There we go. Big decimal. This is kind of static loading and stuff like that it was doing there. Now I've got the big decimal, res 0. I can just say plus 6, and it naturally does what you'd expect. So it's hard to argue that in this situation, something like this, where you've got symbolic operators and infix notation, doesn't make the code more readable and approachable. And you can, of course, add these to your own your own types. Yes, it does open up the possibility of a multitude of sins. I always like to say that Scala brings back taste to programming, and you can exercise good or bad taste when you're programming it. We try and encourage good taste in the people that we train, so that they don't issue horrible abuses. So anyway, that's the operator story. So let's go.
Interesting question from Joshua W1 in IRC, and I think you may have just answered this question by your action. Then the question is, how do you remove things from a REPL, like removing an import that you no longer want?
Yeah, there are ways to do it. Honestly, I just come out of it and restart it usually, but you can also say reset, :reset, which basically, as you say, says forgetting all expression results and named terms, and it resets it to a fresh thing. So now if I was to say res0, for example, it's no longer there. It's reset the REPL back to, yeah.
So if you did that import of big data, for example, and you actually wanted to remove that import but keep any other declarations that you have, is there any way of doing that?
You can basically import things over the top of it, but actually unimporting it is a little tricky. What I could have done is imported scala.math.bigdecimal, which would have hidden the other import. That's probably the easiest way to do it. But yeah, that is something in the REPL that is tricky, is you do tend to accumulate cruft, and after a while, every so often I just reset it.
But it's not one of those long-term things, is it, a REPL? So
no, it's usually I haven't really shown you, but one of the things I do a lot is solve a problem and then use :history, which gives me back a kind of list of all the things that I did, and you can copy and paste this into an IDE and sort of use it as the basis for a solution or a method that you want that fixes the problem, that sort of thing. And of course you can do history for more lines, so last time 100 lines of history from the REPL, things like that. And this history is retained across sessions, so I can see things that I did in earlier REPLs, that sort of thing. Okay, function literals. I think I'm going to skip those because I think most people by now are familiar with lambdas in Java 8, and they're really very similar. Scala uses, I will show you the different notation that Scala uses, which is, instead of the form like this, the single arrow, Scala uses a greater than, an equals greater than. So if we want to say myfun, and we want to make it a function of int to int, for example, then we can just say is, given x of type int, we go to x plus 1. Okay, and that's the full definition. Of course, with type inference, I don't have to supply that a function type at all, so I can just do this instead, and I get back exactly the same thing. And then if I want to call it, I can just say myfun.6, or I can say .apply, which is the actual explicit call of the functions. One of Scala's rewriting rules is that when you do this, whenever you have an object followed by parens, it just calls the apply method on it. So similarly, when we do something like list.1.2.3, this brings together several of the concepts that I've shown you so far, which is, first of all, that list is a companion object, and second, that it has an apply method that takes variable number of arguments, and what it gives back is an instance of list with those items in it. So this is how you get this kind of nice notation, and once you know it, you can write your own. You can just define apply and use these same kind of rewriting rules to make pretty code that does what you want to do. So anyway, that's function literals. There's not much more to say. If you've used lambdas or experimented with lambdas, you'll find that these are incredibly familiar. In fact, I recently did the first Java programming that I've done in about 4 or 5 years for a talk that I did at one of the conferences, and basically it was all in Java 8 lambdas, and it took me no time at all to work in them because they're so familiar. They're virtually identical, and the only thing that did happen was I kept putting semicolons back in my Scala code after writing Java again. which I haven't, I got out the habit of that about 4 years ago, and all of a sudden I find them creeping back in again. So, right, that's function literals.
In
Okay.
Scala, is one of the differences between lambdas in Java 8 and I guess functions in Scala, the fact that you can, because I think there are some, in Java 8, there are limitations about what you can access outside of your scope. Is there a difference there between
There is a
Scala
difference. Scala has true closures, which means that it encloses over any state that it needs. And that includes mutable state. And that's usually a mistake when that happens. There are occasions where it can be useful. Mostly it's an error, a mistake that's been made. And the way that the typical answer that a Scala developer will give you is, well, if you're not using any vars or any mutable data structures, then you're fine anyway. There's no problem. But what Java does is it makes sure that the thing is what they call effectively final. In other words, it's not going to change under you. There are very occasionally, particularly with actors, there are gotchas that people run into and stub their toes on. And for that, a lady called Heather Miller, who's very, very clever, one of Martin's PhD students, is working on something called spores in the language. And what they let you do is detect, they let the compiler detect that kind of mistake. And if you turn them on, provide you with a compiler error that you're enclosing over mutable state and you probably don't want to. And that's some very exciting research. So the idea is that the power and the flexibility of that feature is there, but mostly you probably want to run spores and at least see a warning that you're enclosing over mutable state. Or better yet, in most cases, you probably want a compile error out of it. So that will be something that actually is enhanced in the language before too long, or provided through it'll actually be through a third-party library, but it will be as if it were in the compiler when you use it. So that'll be very nice. Okay, how am I doing? About 10 minutes. I'm going to really chase through these. This is going to be a fairly aggressive kind of set of demos. I kind of want to hit them.
Get tough, Dick. Just
yeah. Well, if you don't get them straight away, then it's more of a, hey, this is some of the cool stuff that you can do when you start getting into it. So first of all, let's and for this I've written a few kind of demos. So let's have a look at the option demo first of all. And this is a type that Java 8 added, only they called it optional. But an option, you notice that I haven't used null in any of my demos, and in fact, null is something that is not used in good Scala code anymore. Null has been kind of removed from the universal concepts of what you do in Scala. What you always use instead are these optional types. So you never have a string that may or may not be there, and it's null if it's not. If you have that, you actually assign it to a type of option of string, and then you have some string or none when you use it. And by doing this, basically what you do is you elevate the thing that was a runtime error, in other words, a null pointer exception, you elevate that into compile time checking so that you can't make those mistakes without the compiler telling you that, hey, you're assuming something's there and it's not there. And so a typical kind of usage pattern of this is here I've got 3 option ints, and in 2 of them I've actually got items in there, and the third one it's this type none, which basically means there isn't anything there. And this is deliberately sort of an ugly form that I'm showing you, but it uses this idea that when you've got these options, you can't just work on the ints inside of them directly, but what you can use is these higher order functions, as they're called. Basically, it's a function that takes another function to propagate through the system this optionality without having to check for it. You just define the things that you want to do, the operations that you want to do, and you end up with an option at the end of the day. And you again, in Java 8 you can do this. There's nothing here that's Scala specific. In the optional type you have flat map and you have map. All flat map does is it does the operation, but also throws away one level of the type that you would get back. So if you have something, if you have a function that takes an integer but returns an optional other integer, if you were to run it using map, you'd end up with an option of option of int. And the flat map simply takes out that inner option because it's useless and gives you back just an outer option of int. So there's a kind of optionality that runs all the way through the system. And another way you can write this is if I choose these basically R4. By the way, all of these methods are safe to run. And when I run them in a minute, you'll see the first one comes up with an option with a value in it. And the other two, because they deal with O3 here, this O3 is used here and here, it ends up being none in both of the other cases, but it doesn't end up exploding. What it gives you back is basically the none propagates through the system, so it's all safe. And the more idiomatic way of writing these is something called for, and this is really the thing that Scala brings to the party that Java doesn't have, is a for expression, which lets you write these rather confusing looking things in a much more idiomatic way. So what we can say is basically for the integer 1 inside of option 1 and the integer 2 inside of option 2, yield, which is going to give back I1 times I2. And this actually gets rewritten into exactly what you see up here. But somebody reading this is able to much more easily see what's going on, which is basically I've got this optional item 1 and an optional item 2. Get them and use them. And if any of these things are none, the whole expression comes out as a none. Otherwise, it comes out as a value. So if I go back into Scala, the Scala REPL, and I can load this in, which will run it. So option demo.scala, and it will load in that file. And there we go, loading option. So there we go, it's defining them. And you can see the result of R1 is sum of 42. R2 and R3 are both none. And R4 is exactly the same code as R1. It's just written in a more readable way. And so you end up with sum of 42. More compelling demo, because this is just optional values. Everybody's like, big whoop. That's not all that interesting. But when you get to futures, this is where it starts to get exciting. So what I've done here is set up a deliberately slow example. You never thread sleep normally. It's one of the bad things to do in what we call reactive programming. But for demo purposes, it's allowed. The rules are you can do it in demos and you can do it in tests, but you shouldn't ever do it in production code. So I thread sleep for 20 seconds just to show or to simulate a really slow operation. And what I'm doing is I'm creating random integers using a future. So this actually spawns a thread and runs it in a separate thread in a thread pool, and the thread pool comes in from the imports up here. And then what I can do is create 3 futures, future 1, future 2, and future 3. They'll all have different random integers within them. But then what I can do is, using that same mechanism that I used before, the for expression, I can get the integer from future 1, and from future 2, and from future 3, and multiply them all together. And the result will be a future, and nothing here will actually block. So even though the answers aren't in yet, and it's going to be 20 seconds before they all come in, I will get back my R1, my future of the result, immediately, and it simply won't be resolved until all the others are resolved. So I'll show you that over here. We'll go into the future demo, load future demo.scala, and you'll see it create the future. Okay, it's doing the imports, creating the 3 futures. Those are the 3 futures. The result R1 is there, and I can say R1.value, for example. And to start with, it tells me that it's none. What none means is I don't have a value yet. It's still doing the calculation. I can also say is completed, and that's false. And I'll talk for a minute, or talk for about 20 seconds. I talked for long enough because now it's actually completed. So now I can get the value. Typically, this is not what you do. Typically, what you do is something more like this. You would say R1 on success, and then a pattern match here to say, I know it's going to be an I of int. I don't actually have to specify the type, it's going to tell me that. And then I can say print line I, for example. And that prints out the value. None of this is blocking. So this is where it starts to get really exciting, is these operations that are very easy to do and translate existing blocking code into can now be done entirely using these very easy to read for expressions and still have the same results. And if we go back to the thing here, what I would have done if these were integers and I was blocking for them and waiting for them, I would have simply basically set R1, result 1, to be I1 times I2 times I3. All you do to make a non-blocking version of this with a future is use the for expression to access these items that are kind of within these boxes and move what the original code was into the yield expression. So this is sort of like the unpack phase, and this is the usage phase. And the result is a completely non-blocking construct that gives you back a future of that thing. And that future I could then use in another for expression somewhere, and you just kind of get into this mode where you never access these things directly. You keep them in their containers, in their futures, and you just work on everything in the future. And it's a very nice way of working and taking advantage of concurrency, parallel processing, all of the good things that you get from threaded non-blocking programming. Okay, I think I would have loved to have shown you implicits, but I've just run out of time. So maybe we'll do the implicits another time. I'd like the chance maybe to come back someday and show you some of those. But you can do some incredible things with those as well.
All right. Well, thanks a lot, Dick.
Oh, thank you.
So it looks like, yeah, so implicits.
Oh, I didn't get to traits either, which would have also been very nice to get to. I could probably do another one of these sometime, should you guys ever decide you want me back, or if you want a different speaker, I can arrange that too. But, yeah, we covered map and flat map and for. The rest of these are sort of type-level tricks that you can do to enhance the compiler and the rules checking. And do a lot more interesting things. Of course, traits give you sort of multiple inheritance without the downside, and many other things like that.
Yeah, this has been awesome. I think maybe because this has been one of the more popular sessions for JVM Languages, maybe we could do a more advanced session, which would be great for both people who are interested from a Java point of view and also a Scala background as well. So. Let me just see.
I'd be absolutely happy to. Let me stop screen sharing so that I can say goodbye to everybody.
Let me just double check.
Let's all do that. Whoa!
If there's any questions.
Startling technical error.
Okay, so what questions do we have right now? Let's see. So Carl Jockle says, how does Scala play with exceptions?
Oh, very well. Gosh, I could talk. There's so many things that are interesting to talk about. So, first of all, Scala doesn't have checked exceptions. It's really, I have to say, I think checked exceptions were a bit of a failed experiment because if you look at it, really after Java, no other mainstream language ever adopted them, and Scala's no exception, so to speak. Pardon the pun. They kicked out the checked nature of it. So the result is it works with exceptions very similarly to Java. The only difference is it actually uses pattern matching to do the catching part because it's really the other way around. Java actually uses pattern matching. It's just that its pattern matching for those things is only available in a catch expression, and you kind of see that when you program in Java or in Scala for a while, you realize, oh yeah, Java's catch clause is actually a pattern match, and it's got all the same characteristics, but it's just for that particular thing. In Scala, you've got a general feature which is pattern matching, so you just use that same syntax, that same feature, to catch the exceptions. The other thing, though, is that Scala has a habit of wanting to lift things up, abstractionally, into the type system. So as well as checked exceptions, which happen at runtime, you have the ability to encode what we call these kind of disjoint unions, things that represent either the correct answer or a failure in a type. And so instead of throwing exceptions all over the place, quite often what you use is something like a capital T try, which has a success side and a failure side. And now you have a value that's in the type system and a type that's in the type system that says, well, the result of this is actually, it's not an int, it's a try of int. And that try could either be successful or a failure. And you have the same sort of advantage that you had with the options or the futures, and that now you've got this, well, did it work or didn't it work? I don't care. I'm still going to do some operations on it, assuming it worked. And if it didn't, the failure is simply going to be carried through the system. So now instead of catching exceptions all over the place, I've just got these 4 expressions that say, well, assuming the thing worked, here's what I want to do. And if it didn't work, at some point in the future, I'm going to find out that it failed along the way, and here's the reason it failed. And so you can write much more robust code and still get all the type checking and stuff like that you got with checked exceptions, but kind of without the downside of checked exceptions, which were heavy to use in practice in Java.
What about closable in try-catch? Question from Milov Tim.
Closable, you can still, if you want to ensure that something is closable, you can of course put that into, encode that into the type system in exactly the same way you would with Java. You can, take some item and specify that it's closable using : closable, and then you know that you can call the close method on it. So then you would do a try and the thing that you want to do, and then a finally block, and say, item.close or whatever. So I think that's pretty much the same sort of thing that you would do. One of the nice things, and of course you can do this in Java 8 now, is Scala has a pattern for this called the loan pattern, which is really sort of the more general form of ARM blocks, or automatic resource management blocks. And the idea is what you do with things that need closing, like a file that you create or an input stream that you create that needs to be closed, is you actually have a method which, given a file name or something like that, opens an input stream on the file. Then you pass into that a function that takes the input stream and does something with it. So when you write it, you actually write, with this file or with file, and then you pass it the function that you want to run on that file. And Scala can then run the function, but then the method that you call automatically does the cleanup that you define. So it will do the finally and the close. So you never have to miss one of those again. You now just kind of, it's called the loan pattern because what happens is it sets up the items that you're going to use, the conditions for usage, passes them in, loans them to you, to your function, which can do whatever it wants with them. And then at the end of it, the original method, which is in one place, is responsible for all the cleanup. And that gets used for other things like database transactions, for example. So you can define a standard method that if anything goes wrong, automatically rolls back the database transaction. And if it works correctly, it automatically commits. And then you just type in your code with transaction, and you get handed the transaction. You can do whatever you want to it, and everything gets cleaned up and sorted out for you at the end of the day. So that's a very nice kind of clean way of doing those kind of things.
And is that referred to as execute around, or?
Oh, maybe. We call it the loan pattern. It may have a different name in the Java world. I'm not sure. That sounds pretty much like it. Yeah, it sounds. Execute around would be a name that I would think kind of applies to that. So.
Okay, a couple more questions. One right from the start, which I left till the end because it was quite general, which is, let me find it. My goodness, where is it now? Here it is. What part does Scala play in big data?
Oh, Scala is really kind of running away with the prize when it comes to big data right now. It's got an awful lot of interest. So one of the things is that the type system, it turns out, is a really big help when you're dealing with big data because it makes everything you can construct all these little building blocks and plug them together reliably because the compiler makes sure that the types match up. So you can't kind of accidentally plug one thing into another. One of the problems with programming in Hadoop, particularly, I have to say, because I've been working in genetics for years, one of the things you learn very quickly about genetics data is it's just all over the map. There's all these kind of corner cases and weird things that happen and stuff like that. And it's very hard to get sort of a reliable processing engine from one end to the other when effectively random things kind of pop up in the code. And when you've got a type system, although you've still got this kind of randomness of data coming in, it doesn't squeak through anywhere. You're actually at every stage you're kind of setting the expectations of, here's what I expect to have at this point. It's a bunch of records that hold sequences, for example. If I get something else, it's going to fail, but at least it's going to fail there, and not sort of continue bumping through the system until some later stage where something goes, what the hell is this thing that I've got? It's definitely not sequence data, but you told me it was. And so, yeah, the typing really helps there. The other big shot in the arm it's got recently is, and you've probably heard of this, Spark is a processing engine built on top of Hadoop, and it has various APIs, but the Scala one has really picked up in popularity, and in fact, in the last 6 months, it's become something of a phenomenon, where people now, we've seen the change in our training, people are now learning Scala because they want to use Spark. And previously, it's been people wanting to learn Scala because they wanted to learn Scala. Literally now, it's kind of turned this corner, and we're getting nibbles from people that say, we need to learn Scala because we want to use Spark, so can you do sort of a Spark-flavored Scala course for us? And we're like, yeah, we can manage that. So it's very interesting.
I saw a huge amount of excitement on Twitter just in the last couple of weeks. There was a conference. Was it in the UK? Scala Exchange?
Oh, yes. Yeah, Scala Exchange. I was there.
Huge amount on Apache Spark.
Yeah, it's very exciting. And of course, the other thing is, although this is not unique, and you can certainly do all of these things in, for example, Java and other languages, but when you get to processing big data and, more importantly, masses of concurrent processing, the idea of immutable shared data really comes into its own. You can't have mutable shared concurrent state. It's just those three things are impossible to put together. Something has to give, so you have to either synchronize things and sort of reduce it to single processing, or do all of these things. If you can eliminate mutable from the picture, which is what functional languages really have a tendency of doing, then you have no synchronization overheads or locks. Everything gets, things get copied when they need to be to work in different threads, but the result is something that runs very smoothly and is predictable and reliable. You don't get deadlocks either when you don't have to do synchronization. So having this kind of immutability baked into the language is really handy. Now, in Scala, it's optional, but recommended. Other languages like Haskell, for example, are much more strict about things really being immutable. And so in Scala, you just have to be careful not to break the rules, and everything will be good. But yeah, having that support is definitely a bonus for big data processing.
Yeah. Awesome. One more question then before we close up, and this one's from D-Spare, which is a great nick in C, if you ask me. One problem I've found with Scala is the proliferation of disjointed DSLs, which create a walled garden within teams. How does one prevent these sort of divergences?
A wiffle bat would work. No, I'm kidding. I think that yeah, it's interesting. I mean, the obvious example that always jumps out to people is a project called Scala Z, which is a very functional-facing library. It's a very good library. It's written well. One of the things that it does is it's basically an adaptation of the Haskell libraries into Scala, and as a result, there's a lot of unfamiliar stuff in there because people using Haskell, if they've used Haskell, know this stuff. They know all these kind of operators that you get. Other people look at it and they're going, wow, I really don't understand this. So from that point of view, it is a DSL. It's one of the more ambitious DSLs. It's not written completely randomly. Some people think, oh, they've just made up all these operators. They haven't. It's come from Haskell. But that's the thing. If it's unfamiliar to you, it's still hard to use. And to that, I would really say just shop around your libraries. There are other ways to do all of the things that are in Scala Z. There are other libraries out there that do them, using English language or whatever you're comfortable with. As far as writing them yourselves, I think it's important, and I did say this earlier on, Scala brings back taste to programming. Java never really had much of a taste. It just had what you could do and what you couldn't do. And sort of everybody, adopted those rules. It was you have getters and setters for fields because that's the way you do it. You just, that's the way Java works, and it has all these it has all these things that people take for granted that they just know, which is their style. But a lot of them are brought about by the fact that there's really no other way to do it in Java. In Scala, you have tremendous flexibility, and one of the first things you do on a successful project is you sort of look at it and you go, I think these are the set of things we want to use. This is the style guide that we want to adhere to or establish. It will be different for different teams. So, for example, a heavily mathematical team will probably edge more towards using something like Scala Z. Mathematicians deal in symbols all the time. Learning a new symbol is easy to them. They make them up. They draw on a blackboard and they say, hey, I'm going to make up this new symbol, which is like an E with 3 lines through it and a cross, and that's going to mean, the exponential square root of pi or something like that. And they're like, yeah, I'm done. So that comes very naturally to them. Other teams that are more of an enterprise-y background will probably find themselves using libraries that match that side of things more, so more English flowing, fluent APIs and stuff like that. And really, it's just important to set the ground rules and the expectations for the teams that you're on, I think.
Actually, Dick, that kind of brings up a question I was thinking about, and not being a programmer myself, one thing I hear often from Java developers is that there's and I think you were just kind of talking about it in my 3-minute internet conundrum from which I returned. But the perception of a very high learning curve for Scala, especially in any case, but even so for Java developers. Would you say that there's been any progress made towards kind of getting that perception to be more realistic? So so as an expert yourself, you might not be able to describe what it's like to pick up Scala for the first time as a junior Java developer.
Actually, I have the advantage of ever since I've been doing Scala, and this is for 5 years now, so I do have a pretty good grasp of the language. But ever since I started, I have been training newcomers in Scala regularly, so I get this kind of constant reality check of, these are the things people find hard. And one of the things that this learning curve is not the kind of scary cliff, walking up to a cliff face and then hitting it, or walking into a brick wall that people think. But the reason it gets that reputation is that it's actually a very nice gradual learning curve, and in fact there are less special rules in Scala, less kind of corner cases and special rules and language what I called law, or twiddles, whatever you want to call them, than there are in Java. The difficulty is that somebody gets Scala, they get going on it, they learn a few things, and then maybe somehow they wander into something like the Scala Z source code or the Scala core APIs, and suddenly they see very, very advanced Scala programming, and it can be very demoralizing to see that, because you're like, wow, I've learnt this tiny corner over here, and these guys are just somewhere else. And in fairness, most of those libraries are written that way for concerns that beginner programmers shouldn't and couldn't know about or care about. It's heavy type system concerns or concepts that exist, like variants, for example, how types relate to one another when they're in containers, and how that affects the inheritance hierarchy. And when you're using Scala as a newcomer, you just don't need to know that stuff. When you're writing the libraries that people use to do that, you absolutely need to know it. So people get into these and they realize, there's a ton to learn here. And there is a ton to learn. The thing is, you don't have to learn it in one go. And if something is too complex, walk away from it until you're ready, is the best advice I can give you. And just go back. There's never been a better time to get involved with Scala. There's a very refined and gradual learning curve that you can take all the way through. And in fact, what you've inspired me to do is write up what I would recommend a newcomer do as this kind of progressive learning experience, and blog it. So maybe that'll appear in the next week or two. So how do I get Scala? But you can start.
How far can just a regular developer get in 60 minutes?
Right.
Just everyone can spend an hour on something, right?
Right. I mean, an example of this is the book Atomic Scala, which is written by two of my friends, Diane Marsh and Bruce Eckel, and it actually assumes no knowledge even of another programming language. They actually teach programming in Scala using very, very short, concise chapters. And I thought when I first read it, I thought, wow, they're not going to get very far. They actually get pretty far in this book. It's not a big book, but they get all the way up to type classes in it, which is a pretty advanced concept, just by building a series of lessons one on top of the other. And people can take it at their own pace. And by the time you've got through that, you have a pretty good working knowledge of Scala. You're not at that point ready to go off and write a full library like Scala Z. That will take more time. But you know, you're already into the productive user phase of it, and you'll probably find that you can write code faster than you would have done the equivalent Java code even by that stage. But you know, 5 years in, I'm still learning the language. It's much less bounded. It's a tremendously powerful language, just like C++ is. You could spend 20 years in C++ and still be learning stuff at the end of it, and it's very much that way in Scala as well. So I guess the advice I would give is don't get discouraged. Any level of learning is, if it's appropriate to what you're doing, is where you need to be. And when you're ready to move up to the next thing, what I find nice about Scala is there's always something else to learn. You never run out of new things to try. So.
And the best place for, I mean, one of the things that Carl was just mentioning in IRC is sometimes it's great when you have like a Scala ninja in the office. Is there an IRC or a forum, or is the best place Stack Overflow or something like that where you can get these answers to your questions?
The Scala groups, Google groups, are a good place to get it. They actually have people from TypeSafe, which is the company behind Scala, sit on there and actually answer questions. One of the things I would warn you is there is still, and you know, it is sad that I have to make this warning, but there are still sort of these hyper enthusiastic people on many of the forums and groups that have a bad tendency to overreact to what they consider dumb questions. And if you get one of those people, don't engage with them, walk away, and somebody nice will answer your question. I promise you that. Just don't get discouraged about somebody jumping down your throat. Like I said, I hate having to give that warning, but it's a very difficult area where we can't just kind of boot people out for being rude. And in fact, all these kind of rules of engagement are still being settled at the moment. But if you ever met, for example, if you talk on there, Martin Odersky gets on there and loves to answer questions, and he is the kind of person that never considers a question stupid. He really doesn't. He's like, if somebody wants to learn, he will teach them. He's an educator, for heaven's sakes. It's his job and his passion. And if you meet like Jason Zaug on there, any of the kind of Adrian Moores, they're all sweet guys and they love helping people. Time permitting, obviously. So,
is that a Scala-user?
Yep, Scala user is a great one to get involved with. I would caution about IRC because in typical IRC fashion, people tend to get very excited on there, and you know, it's not uncommon to see name slinging and things like that take place. So
yeah.
But yeah, that's good. And you know, I'll put a quick pitch in as well because I kind of have to do one pitch, which is if you're a corporate developer and you want a bit more handholding, you want a bit more assurity. TypeSafe also offers something called a developer subscription, which is pretty reasonable. It's like $2,500 a year, and it's priority access, basically, you know, kind of service level agreement response times for questions that you have. And that's directly to the kind of authors of the language and the authors of the compiler and stuff like that. So it doesn't make sense for an individual or for a hobbyist, but if it's a company that really relies on this stuff and needs answers quickly, it's a great way to sort of buy some peace of mind and assurance that things are going to go well.
Perfect. So that's everything from Google Group help all the way up to corporate help. Perfect.
Yes. Yeah. You
Wow.
can get very... Sorry, carry on.
Sorry, go on.
I was just going to say you can get very good help at kind of any level. And like I said, the main thing, if you encounter a troll, is don't feed them. It's the standard. it's the standard advice. Just walk away.
Same as internets everywhere.
Yes, it's the internet's condensed, basically.
Yeah, yeah. Awesome. Well, let me just wrap up and say, Dick, that was a really, really great masterclass, and it shows you've presented this many times, because it was very clear, very structured, and we appreciate your time coming onto the virtual jug. Yeah, well, let's have a chat and see if doing an advanced session on Scala is going to be something everyone wants, and let's make that happen next year.
Sounds good. Okay.
One thing I'll mention just before we close off is, for anyone who has any questions afterwards, I believe, Dick, I made you a host on the meetup. So if anyone asks any meetup on that event, Dick, you should get notified of that. Otherwise, I can ping you. But yeah, you can either take it there or onto the groups that Dick has mentioned. This is our last session in 2014, so the next time we see you on the Virtual Jug, we'll be saying hello to 2015, and we have a number of things that we're looking at perhaps doing in 2015. One of which is perhaps a new Java certification book reading club, and try and get lots of people certified on Java 8 in mass on the Virtual Jug. We're also looking at potentially working with Heather Van Cure and people like that to do an Adopt JSR. With the virtual group, and obviously with Dick here. Dick used to be one of the big podcast givers of the last 10, 20 years, right?
Yeah.
With the Java Posse, which unfortunately came to an end at DevOps this year, right?
I think the unfortunately part of that depends on which side of the work curve you were standing on. It feels like I'm on permanent vacation now after 10 years of producing podcasts. So I still do the Scalawags, incidentally. So we still have a podcast rolling, but it's much smaller than the Java Posse was.
Right. We were thinking about doing something. I guess it's one of those things where it does need a lot of backing to actually get it up off the ground. But if anyone in the community is interested in something like that, let me know, and we'd be happy to host that kind of thing. So yeah, we've got lots in 2015 to come. I have added James Gosling's session in January up onto the meetup. I haven't announced it. That's January 22nd. So feel free to RSVP to that. And as soon as I get the full abstract, I'll announce that on the meetup. But for now, to Dick, Oliver, and all the guys on the meetup, have a wonderful holidays for those celebrating or taking time off, and thank you very much for your time. Cheers, guys.
If you're not celebrating, do at least take the time off.
Absolutely.
Thanks very much.
Bye, everybody.
Bye.